Hello, good afternoon. Oh, come on, we can do better than that. I know you haven't fallen asleep yet. Hello, good afternoon. Hey, all right, there we go. You can fall asleep in about 5 minutes. That's okay, I won't feel too bad then. So my name's Matt Usher. I'm a program manager at Microsoft, and I know you just had lunch, sat through another session. We're in this beautifully lit, dark room, so I'm sure this will help keep you awake. So I'll try to be lively, try to keep you awake. During the course of this, if you have questions, it's a little hard for me to see, so raise your hand. If I can't see you, I apologize. I'll try to kind of block the lights here. I look like I'm staring into headlights here a little bit, but feel free to ask questions as we go. This is completely interactive, so if you have questions, please just ask me as we go. So we're going to talk a little bit about SQL Data Warehouse. I ask lots of questions, so this is interactive, so I expect you or hope that you will answer. So how many of you actually know what SQL Data Warehouse already is? Okay, that's pretty good. How many of you have a SQL Data Warehouse instance? Okay, all right. I won't talk to you folks. I'll talk to the rest of the room, sorry. We'll kind of walk through a little bit. So the agenda of this talk is we're going to walk through a little bit of what SQL Data Warehouse is. For those that don't know, we'll walk through a little bit of the details. And then we're going to walk through kind of a hypothetical scenario. We're going to walk through how a company would go build a data warehouse and some of the kind of choices you would make for loading data and kind of building one of these data warehouses out. It's a little bit of a simple, contrived example, so we can walk through kind of the details more than kind of advanced cases. But I'll talk about kind of the pros and cons of the different ways that you can do this and kind of the different data loading methodologies and some of the tools. So I'll actually show you some of all of this. So let's start with the basics. So what is Azure SQL Data Warehouse? The easiest way to put it is it's a very large SQL Server database running in the Azure cloud that allows you to build scalable data warehousing solutions. It's really built on these kind of 4 pillars you see. The first is this concept of enabling kind of transformative insights. You think about this new world where we have all of this data being emitted, this kind of data exhaust that's coming out of the cloud. I just saw an ad in the last couple days about Fitbit has a new device where they actually are starting to emit telemetry out of this device specifically for fertility. So women who are trying to conceive a baby, it starts to emit data. And using that data, there's starting to be analytics built around that to start to inform decisions. So this is the optimal time to get pregnant during the course of the month. So this exhaust of data that's emitting from all of these different devices and being able to use that data, capture it, and then act upon that data is really coming at the forefront of every business there is. And when we think about that, you think about kind of how do you access that data, you think about kind of the patterns that you have, and the importance of now not working on data that's a week, a month, 2 months, 5 months, 6 months, a year old. Really getting access to that data very rapidly and being able to make business decisions on it very, very quickly. We think about also the integration of all the separate sets of tools that you have to do this. As much as I work in the data warehousing business, as much as I would like to think that my product is the center of the world and nothing else is important as just the data warehouse itself, it's really not. It's the ability to capture all of that data coming in, be able to load that data very efficiently, be able to analyze that data, and then be able to report it out to a human. You think of something like a table that has a couple of billion rows. Well, a human can't interpret that. It doesn't make any sense. But if you put it into a chart, it can make very simple sense to a human. You can see trends out of that data, for example. So being able to connect to all of these different services and build a solution and not just these individual components that a data warehouse is. The second really pillar is around the way the service is built. So Microsoft introduced the Azure SQL Data Warehouse about a year ago out to the public. And it was the first service in the industry that was built on this concept of separation of storage and compute. And the idea is that as a user, you have a limitless value of being able to say, I have this set of data and I need this amount of compute. And this is truly the premise of the cloud. You can think about the idea of the cloud as this burstable component that you could say, I need X today. Whatever X is, whether that's a lot of storage, whether that's a lot of compute, or some balance between. And being able to dynamically adjust that. And so really this kind of concept of being able to scale very quickly, being able to adjust to business needs, not on, hey, I have to go buy some servers, I'm going to provision these in. I think we all probably remember the early days of Twitter when you would see the fail whales, the famous fail whales, because they ran out of capacity. So the premise of the Azure cloud is really this infinite scale. So adding compute when you need it. We'll talk about that a little bit in depth. And then really kind of this third pillar is really around securing your data. We all see the break-ins. There was the Yahoo announcement just the last couple of days talking about security break-ins into these environments and really making sure that your data is secure no matter where it is. So the Azure cloud and SQL Data Warehouse provides a lot of ways to secure your data. And you can control who has access, you can control how that access is monitored, you can log all of that access, and then you can secure that data, so you can encrypt it in a lot of different ways to make sure that it's secure, that only you and your company have access to that data. And then finally, obviously, this is a cloud service. So you can go provision one of these things very fast. It takes about 3 to 5 minutes from the time you click create on the portal to actually having access to this. It's SQL Server based, so your tooling experience, your development experience transitions very well from SQL Server right into the SQL Data Warehouse service. There's some additional knowledge that you'll have to learn, but really it's this concept that it's SQL Server, and so all of the tooling and infrastructure, ecosystem investments that you've made in those areas can really transition into this new world with the cloud. You don't have to go learn a new set of technologies. You don't have to go learn a new language. You can just transition the environment you have, transition the skills that you have very, very quickly to the cloud. So let's kind of walk through a little bit more in depth about this. So we think about kind of where this sits from a product perspective inside of the Microsoft ecosystem. And we talk about this Cortana Intelligence Suite. And this is really that concept I was explaining where each one of these components is not really that useful in and of itself. It's these solution plays. So all of the data coming into the system, being transitioned through things like the Azure Data Factory service, which allows you to gather and pipeline data from one service to the other. Be able to ingest things like event hubs and a bunch of IoT data. You imagine all these devices. We walk around with our human tracking device or our cell phone that's emitting data constantly. Being able to take that telemetry, ingest it very rapidly, absorb it, let it scale when it needs to, and ingest it and land that data. In the middle, being able to store that data. So we talk about things like the Azure Data Lake Store. For some reason, I don't know what happened here. HD Insight usually kind of transitions between data store and some of this machine learning and analytics. So somehow the slide got messed up here. But really think about those kind of large data solutions of storing data, being able to land data in one of these solutions, being able to access it very quickly. And then being able to learn or build knowledge on top of that. So things like Azure Machine Learning and Data Lake Analytics, being able to ingest data and then understand that data. So as a human, being able to make sense of, it looks like something's going on in our Midwest region because sales are starting to fall off. And being able to intuitively understand that from a large set of data and being able to get some insight. And then finally being able to push that data out to people. The end result is to perform an action. So how does a human interact with that? Whether that's an alert to a device, whether that's a report that you get emailed to you first thing in the morning, or some kind of other interaction, whether that's your device starts to alert when something else happens. And so you can take all of this intelligence and start to perform new actions that we're not capable of doing just simply 2, 3, 5 years ago. There's a transformation in many industries now based on all of this new data that can be exposed and then be informed and make decisions on very rapidly at either near real time or real time kind of information flowing through systems. So being able to kind of figure out how to put all this together is really kind of the complex nature where we are today. So when we think about this, we look at kind of the way that SQL Data Warehouse kind of works. It really sits in the solution of what we're talking about here. It's really the ability to absorb all this data, store the data, and then get insight out of it. And it sits in between kind of some of these front-end solutions. So you think of ways that you land data, things like in Blob Store, or ingesting data into Azure Data Lake Store, event hubs, or through Stream Analytics. And landing that data and being able to make sense out of it. And then using front-end tools like Power BI and Excel and others to be able to go visualize that and connect very, very quickly. We talk about kind of real solutions. So it's easy for me to stand up here and say, hey, this is this great world, and here's what we could do with it in theory. And so I'll have some peppered quotes throughout this deck that'll talk about kind of what customers are actually doing. There's a great quote here from Christoph over at jet.com, and they have a hybrid solution. They have all of their front-end telemetry, all of their pricing information lands in a HD Insight cluster running in the Azure cloud. And they use that as their landing location or a traditional data lake store. And they have all of their raw data in there. And they do once-an-hour aggregations. They take that data and they land it into SQL or Azure SQL Data Warehouse. And they're able to then start reporting and acting on that data. So what are our competitors doing with pricing? How many customers are looking at this category of product and being able to make platform decisions? Maybe we're going to go promote a product category because we see it starting to get hot. Maybe we want to push that even further. Or maybe we want to merchandise a little differently. We see a category that people are starting to search for that we don't have a large set of products for, so we're going to go invest in finding a connection to one of our suppliers and say, hey, maybe we can make a real-time decision. We want to go purchase these 5 extra categories into this big, large product category. So we can offer that to our customers. And really being able to do that. And with their scale, you can imagine, jet.com is a large online retailer. They're able to take all of that data, ingest it through the system, land it, and make action or take actions on it very, very rapidly. So we talk about things in hundreds of millions and billions of rows very, very often with them. And it's a common conversation that we have. How do we ingest, move that data quickly? So when we think about kind of the way the service is built, they started with this kind of separation of storage and compute. We're going to kind of stay in this lane for just a little bit. We introduced this concept of a data warehouse unit. So does anybody know what that is? Awesome, there's one person in the room. You're my volunteer, you get to come up on, no, I'm just kidding. A data warehouse unit is a concept of a guarantee of performance. That's really what it is. You can imagine in something like the Azure data centers, we don't run a single variation of hardware. We have multiple generations of hardware with different configurations, different CPUs, different CPU clock speeds, different memory segments, different memory types. And so what we do is, instead of trying to expose that all to you and say, oh, you happen to be on this set of servers, so this is the configuration you have, or you happen to be on this set of servers, you get a different configuration. It's just confusing to everybody. We have this concept, which is really based on this concept of a power unit or a block. And you essentially buy things in these blocks. Under the covers, Microsoft and our team manages all that infrastructure, so you don't have to worry about, hey, am I going to get put on a slower cluster? Do I have to deal with that? What am I going to do about it? But in the cloud, really all of this is handled for you. This is the premise of a PaaS service. So we're able to take advantage of the new hardware. We're able to give you either better performance or cheaper price as we move into these new generations of hardware. So really optimizing the infrastructure. And this is the premise of the cloud. So there's a great example of why this is all really important. We talk about kind of this concept of having all of these servers and this capability of growing compute. It becomes really, really important in this new world. Everybody has their favorite, like, hey, I wish we were, I wish we had created the concept of Facebook before Facebook did, right? And the thing just grew like crazy. And how would you deal with that? You see relevant examples. Twitter went from 0 to massive in a very short amount of time. Everybody talks about the length of time that gets to 50 million users. You think about things like Uber or Lyft, and some of the abilities for those companies to go from nothing and be a massive industry changer in the course of months, and to be able to scale very, very rapidly. Traditionally, if you had to do this, you would basically get on the phone with one of your IHV vendors, be ordering servers and trying to find space in a colo facility somewhere and building data centers out as fast as you can. And now in the cloud, you have this premise with the Azure cloud of just scaling the service. So Paul he's a CTO over at Pound Sand. Probably most people, does anybody know what Pound Sand is? Oh, awesome, good. All right, nobody's heard this story probably then. So Pound Sand is a very small gaming company based in El Segundo, California. They're a bunch of former EA gamers. They went off and started their own game studio, and they produce iOS games. So they built a game that they're really proud of. It's a very small company, under 20 people in the company, and most of them are game developers or game designers. They don't really have a lot of experience with developing large-scale data warehouses. And so they had originally started on MongoDB, trying to run their analytics for the back end of their system. And they do kind of traditional things that you would expect of a gaming studio. Where do people get stuck in our game? Where do they get lost in the maps? What are the things that they're buying in our games? What are the things that they're not buying and can't discover? And so they do that kind of in-game analytics. And so they had their game running for a while, and it had been out on the iOS store. And they had about 3,000 to 4,000 gamers running on the game at any one point in time. That was kind of their daily rates. They happened to get lucky and were featured on the front page of the iPhone App Store, Plastic Squad. And all of a sudden, within 48 hours, they went from 3,000 gamers to 300,000 gamers. And you can imagine the strain that this would put on a system. And simply the CTO went online, slid a slider to the right, gave the system more power, and it absorbed the crush immediately. It took about 60 seconds for him to resize the system to absorb that crush. And it was really that simple. He didn't have to think about, oh no, now what do I do? Do I go scale out services? Do I build servers? How do I deal with this? It was simply go in, slide a slider, moving on. And the system continued to perform for them. So they were able to absorb that crush very, very simply. Didn't bring their business down, took advantage of the opportunity of them being featured, and they won a bunch of gamers. And so it was really the ability for them to have that continuity in their business by having this ability to scale from size to size. So I'm going to actually flip through a bunch of stuff. So I'm going to show you what that looks like. We'll flip over to my laptop here. And we'll log into the Azure portal. And I have a couple of things set up here. This is the portal view of the Azure SQL Data Warehouse. This just happens to be a database I created about an hour ago. And it's as simple as this. And I just wanted to visually show you what this looks like. And so this is really what that CTO did. He went into the Azure portal, and he saw this is what the setting is. In this case, it's set at a DW1000, which is the lowest scale. And I'm waiting for connectivity here in the room. It's a little slow. But really what he did was he simply went into the slider and he said, I just want more power. And it's literally as simple as doing this, clicking save, and yes. And now the database will start to scale. Behind the scenes, the service is now adding additional compute, refactoring the way the data is set against that compute. And in just a minute or so, so the slider's now disabled. It's telling me it's scaling. And in just a minute or so, the service will actually come back. And we'll leave it here so we can actually watch it. And the service will come back now at a much larger scale. So you've just added compute in just a very short, rapid amount of time. And this really gives you the ability to change the business as you need it. So no longer are we having conversations that sound like this. Hey, you have a data warehouse. What's the biggest problem you have? Generally, it's ETL. What's your SLA around ETL? 2-3 hours. Okay, how much data do you have to push through that? About this much. Okay, let's start doing backwards math calculations, and we start having a conversation that sounds like, hey, you're going to need N number of cores. You're going to need this kind of disks with this kind of spin rates. You're going to need, this configuration. You need this backup configuration. Anybody heard this conversation before? Right? We've all had this. The problem with that conversation is your boss didn't ask. So we have a problem with Midwest sales. What do we know about it? Did you answer that question with, well, it takes 10 cores to answer that question? You didn't answer that. You answered, hey, this is what's going on in the Midwest. We have this data. We can do some insight. We can build some reports. We can investigate the data. And you can find an answer. Right? Your boss doesn't want to know how many cores it takes. Doesn't care. Right? It doesn't help your business move forward. So being able to see, hey, very quickly, I can go in and look at the data, and I can see the data, and I can make decisions very rapidly. And we don't have this technical conversation, which is a detail that doesn't drive your business forward. Really gives you the ability to start to move forward. I'm going to go pivot and go back to the screen. For some reason, Essentials was not there. And you can see the service is now online at a much larger scale. So just standing here on stage, I slid it right, click save, and now we have a much more powerful SQL data warehouse that we could use. And we don't have this conversation. I don't need to think about scale because in a moment's notice, I can, just as easily as I scaled it up, I can come back into the service and I can say, scale it right back down. I'll click it again. And so this service just expanded and contracted very, very rapidly. And the power of that is now you can start to optimize the way that the service runs. So in that ETL scenario I started this conversation with, we can think about the service in the morning when you need the power to be able to scale the service up, use the power of this burstable compute, and when you're done, scale the service right back down to save your business money. There's no need to run that compute because generally generating reports doesn't take that much compute power. So you can really have this on-demand need of when you need that power available to you just by going into the Azure portal. And you can see the database scaled right back down. Yeah, so all of this can be scripted. It's a great question. So this is all scriptable through T-SQL code. So it's as simply as alter database, modify service objective, and you can set the new objective size, which is essentially the DW setting. You can also do this through PowerShell, so you can script it. So you can call this via REST API as well, so through something like SSIS. So at the beginning of your package run, you could scale the service, run your package, and then scale down at the end. I see a couple of questions here. Yeah?
Yeah, for the hour, do you pay for the highest performance that you...
So for the hour, so I'm going to repeat the question. So for the hour, do you pay for the highest level of DW setting, essentially? Yeah, the answer is yes. So you'll pay for a maximum amount of DW used in that hour, and it's built on an hourly basis.
That's CPU.
What's that?
So when you increase that, you just increase the CPU?
So when you increase DWs, did you just increase CPU? Is that the question?
Yeah.
Okay. So it's a combination of things. You actually increase CPU, memory, network I/O, and then local storage as well. So you increased a bunch of things, not just one. And that's why it's not as simply as, hey, we're going to give you 4 more cores. It's a combination of all those.
Is there a feature to auto scale?
Is there a feature to auto scale? What do you mean auto scale? Make sure. Okay, so the concept that you're asking for is the ability to auto scale based on kind of workload usage. Does it do it automatically? Today, there's not a feature for that. It is something we've thought quite a bit about. We wanted to start with, let's get the thing working first and then start to introduce this. There's other examples of this. Azure Websites does this. You can policy-based say, I want minimum number of nodes and maximum number of nodes, and then set the value that you want at, say, CPU percentage to be able to force the system to scale automatically. So there's a pattern within Azure to do it. We just didn't introduce it with the service, not at our original GA. So I'm not going to address future stuff here. Catch me afterwards, and I'll actually walk you through kind of how we gather feedback from customers. This one specifically is something we've talked about. I've talked about it publicly at other talks, so it is something we've talked about. We just GA'd this service, kind of stepping back for a moment. We just GA'd this service in July of this year, And so we've just gotten the service fully to GA. And so there's a next wave of set of things coming beyond that. So, okay. All right, so one of the things that I didn't mention here was this ability to pause. I kind of passed over this very quickly. So a lot of times you think about an enterprise data warehouse where this is the thing that's mission critical to your business. And so you have it on 24/7. It's running all of your reports, all of your analysis, all of your dashboards. And so you're never going to shut that off. But there are many other situations where you do want to shut it off. And you think about all of the value in the cloud. The ability to turn things on and off when you need it to optimize your business is an essential component of that. So when we think about the service here, remember I started with this concept that storage and compute are separated. You can literally just hit a button and say pause, which is essentially saying make it DW 0. And when you think about cloud services, especially in kind of the last several years, storage is cheap. I mean, let's be honest. There's this race happening. And I don't know if you're paying attention, but Microsoft, Amazon, and Google are all racing to see who's going to give you the most storage for free. That's where it's going, right? Storage is a commodity business this day. Storage seems to drop about 15 to 20% year over year. So you can just do the math, right? Storage is becoming cheap. You can store more for less cost. Really, the value in all of these cloud services is in compute. Well, if you have a scenario where you have data marts, maybe you have a data mart for finance, or maybe you have a data mart for marketing or sales, and you don't need to run that all the time. Shut it off on a Friday, come back on Monday and start it again. Save yourself the cost over the weekend. It can be scheduled. You can go through the process of managing all of the infrastructure, turning it on and off. Maybe it's a development environment. Maybe you want to bring up some stage environments. You can do all of that by simply just clicking a button. Again, scriptable, so you can run this through any one of the tools I mentioned, T-SQL, for example. But you can literally go and just kind of turn the system on and off. Now, we have a great use case for that. There's a company called Integral Analytics. And what they do is they go and take all of this information from utility companies. And they say, how are utility companies, all these new smart meters attached to your house? They ingest all of that data. They run a bunch of analytics over the top of it, and then they turn their system off because they go sell that report back to the utility companies once a month. They're essentially an outsourced analytics company. And so they're able to ingest all that data. They run for about 3-4 days at the beginning of the month, and then they turn the system off. But when they need to start at the beginning of the next month, they just go and turn it on again. They don't have to back up or restore data or go configure a new cluster. They literally just go in and hit play. And it starts the system up, and they're able to operationalize their business this way. And it's a significant amount of cost savings. For them, you think about running a service for 3 days out of the month, and you're saving 90% of the cost of what they're spending in running a service. So it really gives them a way to optimize COGS and costs in their own business. And it really gives them the opportunity to take advantage of this premise of the cloud. I can get resources when I need them, and I don't have to purchase them and hold on to them for an infinite amount of time. So when we think about that, then you think about, well, this is Microsoft and this is SQL Server, so we play nicely with SQL Server stuff. But in the last couple of years, Microsoft has made a very concerted effort, again with SQL DW as well, to be able to open the ability to access these services, essentially from anywhere. So Microsoft has introduced Linux drivers and ODBC drivers for Linux. We've introduced JDBC drivers for Java, and a bunch of different kind of driver connectivity aspects to be able to get at this from wherever you are. Ultimately, these are PaaS services, so you don't have to worry about what the OS is running on it. You just need to be able to connect and interact with them. By enabling all of this way that you can connect, this also enables a lot of the tooling that's out there outside of Microsoft. So not only Microsoft first-party offerings, but all of the third-party offerings in the marketplace. So other tools that you may have in place already. You don't even have to change those environments. There's the capability of connecting and using this service by using the languages and the tooling that you already know. So we're going to pivot here a little bit into kind of how this all works. So essentially the way that this system works is it's kind of a broken down system in an MPP system. So I saw a bunch of people that have played with SQL DW. So how many people do not know what MPP is? It's okay if you don't. I have a really good story to tell you. Okay. So there's a few of in the room. So the way to think about this is I use an analogy. I'm full of stories, and I apologize if these stories don't make all that much sense, but this one should. So imagine we were going to build a wall. There's quite a few people in the room, and we could do this. This is a great example. We have a pile of wood sitting up here, maybe a hammer and some nails sitting up here, and we could build a wall. It's not that hard. And the way we're going to build this wall is we're going to have each person come up, they're going to grab the hammer, grab a nail, put a nail in. And the next person comes up, hammer, nail. Right? We'll repeat this over and over and over again until we build a wall. There's quite a few of us, so it'll take a little bit of time for us to get through this, but eventually we'll build a wall. So this is the SMP model. This is kind of a shared architecture where you think of cloud services and you think, or traditional box software, they share architecture. So you have a shared set of cores, you have a shared set of disks and buses and all of this stuff inside of the system. That's one way to build things. And you could optimize this, right? We could go, well, maybe we want to build faster core. So instead of a hammer, maybe we get a nail gun, right? So we can hit nails a little faster. Or maybe we go, well, we can only get so fast with that. So we hit Moore's Law and we go, well, let's kind of change this. Instead of maybe one nail gun, maybe we put 4 up here. Maybe we put 16. It's still going to take us a while to get through that, right? We still have to share those 16. So it takes really long. The MPP model is exactly the opposite. It's a shared nothing architecture. The idea is that individual components work in concert with each other with a coordination layer that allows them all to work independently. So again, we have our pile of wood up here. Everybody has a nail. Everybody has a hammer. One person standing in the front says 1, 2, 3, go. Everybody hits the hammer. Everybody hits the nail. We're done. It's that quick. Right? It's the coordination and concert of all of these individual resources. So all those things we could do on an SMP, we can optimize for each person. But as a coordination facility, you can imagine all of the people in this room all hitting a hammer and a nail at the same time, and how much faster we can operate on a procedure instead of having something being done in some serial fashion, no matter how many kind of running threads you have. And so this is the concept behind an MPP system. Now, when we think about that, and we start to think about how this service is built, this is really a critical part of understanding the way that this is all going to be kind of functioning in the system. So we have this concept, if you're familiar with Hadoop, Hadoop calls it a head node, we call it a control node. Essentially, it's the traffic cop. It's the person saying 1, 2, 3, hit the hammer. And the job is to take all the information from the executing query, send it all to the individual nodes to execute, and then aggregate and return the results. And that's really what it does. Behind that, you have a set of compute nodes. These are individual SQL Server instances running a fraction of the data to be able to execute your query. So if you think about that hammer and nail scenario, it's the individual person. And they have a set of the data, and they're able to operate independently of everybody else. They don't have to worry about what the person next to them is doing. I've been given a task, and I can go execute it. And it's this ability to scale. Finally, the last part of this is the separation of storage. So we take all of the data, and it's placed in Azure Blob Storage. And so the data is now remote. And so the storage, when we resize things, for example, the Achilles heel is always in moving data. So if we don't have to move data, we can do all of these operations very, very fast. And so that's how you can see us resize very quickly. We didn't have to move data. If anybody's ever copied a very large file from one drive to the other on your machine, you just watch the little Windows dialog copying, right? Calculating, I'm going to take 7 days to move this file. We start talking about things in tens of terabytes, hundreds of terabytes, petabytes of data. You can imagine how long that calculation is. 19,000 years, we'll move your data kind of thing. And so the ability not to have to move data, to be able to effectively work on very small shards of the data, is really the way these systems are designed to perform at scale. And so now let's walk through kind of how a query would work in the system. And the reason I'm explaining this is as a lead up to how then we're going to go process data. And I'll explain how this makes sense, and I'll tie it together, I promise. So when we think about a query coming into the system, you have a query that comes in. The control node creates what we call a distributed query plan. It sends it to all of the nodes configured in the compute cluster. And then those go out and actually hit the data. They pull the data in that they're represented to work for. They calculate the results, and they send it back through. And from a caller's perspective, you have no idea that you're working with a system that has n number of components under the covers. It looks just and acts just like SQL Server of any other form. And so really this ability to then generate a query that gets distributed and run through very fast works just like the way that you're familiar with. So here's a good example of T-SQL code. We're just going to count the number of rows in a table. So pretty straightforward. And if we watch what happens in the system, what will eventually happen is the compute node at the top will go generate a plan. Oh, I don't know why that says select sum. Just caught a typo in my own presentation. So you see the select at the top, and essentially what's happening is now each one of the nodes has been given a select count star. So go down, return the number of rows that you have, and the control node in this case will aggregate the results and say, okay, I got 10 rows from the first node, 12 rows from the second, 10 rows from the third, and it does the math very quickly and says, oh, I got 32 rows, and it does that all in front of you without you even having to interact. Do I have to shard the data? Do I run a distributed query? All of that is handled and managed for you. And so the ability to then have these shards of data and the scale out is really what makes data loading and performance of these systems kind of the goals of meeting these needs when we start talking about things at very large data sizes. All right, I will pivot once more, and the last kind of component of this. So one of the things that we've introduced with the service is this ability to, we call it auditing and threat detection, this ability to manage what's going on in the service. There's a set of capabilities underneath this that is built on taking all of the data that's coming into the system and being able to run machine learning algorithms across them to identify attacks. That's essentially what it's for. And the reason I introduce this concept is you think about these data warehouses and you start to worry about, well, my data's in the cloud and what can I do with it? There's a fascinating kind of experience that I and my team and folks at Microsoft have gone through in the last several years. When we worked on SQL Server previously, you can imagine what the experience was looking like when we got feedback, for example. It's literally what happens. There's some PM, looks like me, sitting in a cube somewhere and goes, hey, I talked to this one customer at a conference. They came up and they said, hey, I really want the red feature. Why don't you have the red feature in the next version of SQL? Okay, kind of sounds good. It sounds like a good idea. Maybe we should go build that. So I sit down, I write a spec, I convince my developers we should go build the red feature. And we spend a lot of time on it. We get it into code. We finally put it on a version that we give to you as a customer, maybe an early tap customer. Maybe 5 people actually ever play with it. Maybe those happen to be the 5 people who wanted the red feature in the world. They're the ones interested in it. Oh, I see the red feature's coming. Let me go sign up and go play with that. They go, it's pretty good. Here's a couple small little improvements. We'll fix it, right? And what happens is then we go, oh, great, we got some good feedback. We're going to go ship this thing. We put it on a DVD. We put it out in the world. And the world goes, why did you build a red feature? We wanted blue. Right? The ability to gather feedback in the system is something that the cloud has enabled. So now, today, when we deliver features into the cloud, what this means is we're able to get almost instantaneous feedback. We can see what's going on in the workloads. We can see how people are using the system. We can optimize the way the system is being run. But more importantly, we can look across the breadth of all of the systems running and be able to make smart decisions that help you move your business forward. So when you think about threat detection and auditing, coming back to this, what this means is that we're able to take advantage of the 1 point whatever million number of databases we have running SQLDB, the number of databases we have running Azure SQL Data Warehouse, and we can start to look at patterns. Under the covers, we have machine learning algorithms that are looking for things like, hey, here's somebody who's all of a sudden doing something they weren't doing before, and alert you to, this looks like an employee who's about to leave your company who's dumping all of your customer data. It's something you might want to know. And so you can use these algorithms that are being built behind the scenes with the scale and the feedback that we're able to receive, and we can iterate very fast and offer you kind of these capabilities. So threat detection is a great example of that. And in this case, what it means is all of those learnings at scale start to grow the business much, much faster. That feedback loop I was talking about really becomes something that we can take in the matter of hours. We release a feature, and honestly, Twitter tells us whether we did it right or not. A bunch of people will start complaining if we did it wrong, and a bunch of people will say, hey, this new thing is great. We should go start to use this. And that's really how we get feedback now. It's this kind of almost near real-time feedback on what the services are doing. And when we think about this, these questions like somebody here in the front was asking me about auto-scaling, for example, we've seen that. We've seen the ask on things like our feedback forums and in Twitter. And so our ability to gather all of this data and then make decisions on that and do that at scale. Now, the reason I'm talking about this with the cloud service is you think about something like you have a data warehouse running in your business. Teradata, Oracle, Netezza, SQL Server, whatever it is, and your ability to action on that data is isolated to you as a small company. The ability to action that across millions of databases and understand the patterns and the behaviors and be able to use that to train models to learn how could the system go better, how could the system go faster, what kinds of queries are people running, how can we optimize those, how can we optimize loading patterns, are a capability that we now have and can offer back to you as a customer. We can learn from all these, implement features that are really useful to you, and move your business forward. So closing on auditing and threat detection, this is really the ability in the service to then go look at those patterns of things that are happening and alert you. Here's something that looks like it's going wrong. Here's somebody who's running a set of password crackers against your database trying to get in. How do you deal with that today? So the system can alert you and send you an email and say, hey, it looks like this account is being attacked. And you can go perform action on that without having to think about how to secure your database. It's happening automatically. So I'm going to introduce to you, we're going to kind of pivot to, now let's put this all together. So I'm going to introduce you to a company called Adatum Corp. It's one of Microsoft's fictitious companies. So you can go to the website and it'll just reroute you to Microsoft.com. But we use this as a sample company. And so I'm going to build a use case for you, and then we'll actually walk through how a company like this would go put all of this together in a data warehouse. So let's kind of build this company up. So let's assume that they're like a multinational utility provider. They have those little smart devices on your water meter, your electric meter outside your house that are now emitting stuff to the cloud, and it can tell you how much energy you used in the last hour, right? You have a little app. And as they're doing that, they've been in the business for a long time, so they have some people who have the old meters, you have some people who have the new meters. So you have all this kind of combination of data. You have some data on premise, you have some data being born in the cloud. These new meters are maybe submitting data up to an event hub or Kafka or something, and they're being able to stream that data and land it in, say, an HDN site. So there's really kind of this new world of these environments like this. And we can contrive a bunch of examples, and there's a bunch of real examples like this. But this is really kind of the state of many businesses today. And then finally, you have this kind of variety of tools and experiences. So maybe they know SQL a little bit, maybe they have some Java in their background, whatever. So they have this kind of mixed environment. This is a pretty classic case. We see this a lot. So let's kind of talk about, we're going to kind of build a very simple data warehouse here. We're going to kind of work through that here in the next 30 minutes or so. And we'll talk about kind of how we would load data into the system. I'm not going to show you any fancy Power BI reports. There's a bunch of other sessions that can talk about how you go build analytics on top of this. I really kind of want to show you the nuts and bolts. So there's a couple ways that we can load data into the system. And these are kind of the three basic ways to do it. You can do it with the traditional tools that you always have used, so traditional ETL tools. So for Microsoft, you think of SSIS, SQL Server Integration Studio, or some of the big kind of heavyweights in the industry, Informatica or maybe Attunity, is loading kind of patterns for being able to get data from a bunch of different sources into a database or data warehouse. We're going to introduce a technology called Polybase. It's been something we've had in our on-premise business for a while. We introduced it with SQL Server 2016 to the masses, and I'll walk you through what that is. But it's really the ability to generate, a T-SQL statement and load data from a non-SQL Server instance. And I'll give you a real use case of that, and we'll actually walk through how to configure and set it up. And then finally, with the cloud, we have these new sets of pipeline tools. So I've picked two here. One's the Azure Data Factory service that's available for Microsoft. I actually picked the third-party one, so Redgate's Data Platform Studio. And I want to show you what capabilities exist outside of Microsoft as well. Again, I do work for Microsoft. I would love if you run nothing but our stuff. How many people in here run nothing but Microsoft stuff? Yeah, exactly. Who has a Windows phone? Let's try that one. Anybody got a Windows phone? Hey, there's a few. Wow. All right, I'm proud. It's okay. But really, our team is smart enough to know data warehousing is these very heterogeneous environments, right? Nobody runs just a full Microsoft stack. Generally, nobody runs a full stack of anybody, right? I've never heard of a customer who says, we run nothing but Teradata. Oh, that's interesting. What OS do you run it on? Well, Linux. Okay, so that's not just Teradata, right? There's these just very heterogeneous environments. So I wanted to show you kind of a complete solution, not just the, hey, here's the Microsoft frame and how you would think about it just from us. So let's start with kind of a simple example. So if you come from the SQL Server world, SQL Server has a tool called bulk copy exe or bcp.exe. It's a simple command line tool. And what it does is it allows you to copy data in and out of SQL Server very fast. And so I've set up just a super simple example here. And you'll watch it here. It's just a simple batch file that's calling BCP. Now, what this is going to do is it'll eventually connect up to a cloud data warehouse, and it'll start to import some customer data. Now, batch files aren't super interesting, so let's kind of build this case out. We created our new data warehouse, and we want to go, actually create some tables to go load this data into. And assuming in this case, it's coming from SQL Server, so it's actually coming from SQL Server running on my laptop here. So if we go look at the T-SQL code that we'd have to generate to go create this table, we're going to create just a simple customers table, and added some additional details here. It's not required, but essentially the way that we want to lay the data down in the system, we can define how the data gets laid down in the system. There's a lot of kind of technical talks that have been pushed out from Microsoft into our online resources. You can go learn about kind of table distributions. I'm going to kind of gloss over it here. And then we're going to use clustered column store indexing, which is a new indexing methodology that was introduced in SQL Server 2014, which is essentially storing data in columnar format instead of row format, optimized for data warehousing scenarios. So I'm just going to go create a simple table. I'm going to call it the customers table. I'm really creative here. And it's just got a couple of columns. So an ID column, first name, last name, language, and gender. And it's really pretty simple. Goes out, creates the table. And just for fun, I'm going to go just, traditional T-SQL code here. I'm not doing anything fancy. You can see I'm just going to insert a single row, and I'm going to insert my own name and my own details here. And then I'll go just check that data. So you can see. So just getting started, you can see very easily, I can use all of the skills I have from SQL Server. It's pretty straightforward. I don't have to do a lot of retraining of myself. It's select star from table. It's pretty much the same technologies you're used to from the last 20, 25 years of SQL Server. But if we head back over to this file, and what it's going to do is it's going to go look through a common delimited file, and it's going to take all that data and it's going to shove it into that table we just created. And you'll actually get to see the command here, so bcp exe. And again, it's really exciting to stand here and show you these really classy demos we have of command line. But what you see is it just added 10,000 rows. So it just took 10,000 rows from a file and shoved them into the cloud, ran it from my laptop into the actual Azure service. And if we go back to that and we run that query again, you'll see all of a sudden now I get a bunch more rows. And you'll watch the row count over here in the bottom right start to pop up as all that data is being returned here to my laptop. And again, it's a little slow here because the connectivity from my laptop in this room is not the best. I think we're all sharing Wi-Fi. So whoever's streaming in the back, if you want to make this demo go faster, shut that down, please. But you can see it returned 10,000 rows. So that same table, I didn't do anything, we just loaded a bunch of data into it. So very, very fast. So it's a quick way to do this. The optimal reason to do it this way, and this is kind of the trade-offs I want to talk about as we go, is that this is a fast way to do it. Small data sets, it's pretty easy, but this is a single-threaded model. So it's taking data from one location of file, and it's pushing it through the control node and then distributing it out. So very, very kind of optimized for these kind of small scenarios. So 10,000 rows. So let's make this a little harder. So I'm going to pivot back to my deck for just a second, and we're going to introduce a technology called Polybase. Now what Polybase does is it gives you the ability to query from T-SQL code into something that's not SQL Server. And so this was originally built on premise. We have a technology or a product called the Analytics Platform System where this was originally built, and allows you to query from T-SQL code into Hadoop. So you can imagine you have a bunch of data sitting in a Hadoop cluster, and you write a bunch of T-SQL code, and you can pull that data out of Hadoop. It's an intelligent solution, so it has all kinds of capabilities. You imagine that Hadoop data is a very large data set. You don't want to stream all of that back to SQL Server. So it can optimize using kind of standard SQL Server technologies, creating statistics, for example, on the table. It can actually go out and generate a MapReduce job, push that into Hadoop, execute the MapReduce job, generate the results, stream those results back to SQL Server, and then join them just like you could any other table. Now there's real use cases of this. Since I've been in Atlanta, I've been in about 6 Ubers since I've been here. It's kind of the way I've been getting around. It's kind of easier rather than riding the buses around the Beyonce concert last night. So I was happy to take Uber instead of take one of the buses. But you look at kind of this ability to query unstructured data and you go, well, what can you do with this? So there's a great example. There's a company here in the US called Progressive Insurance. And they're a traditional insurance company. And what they've done is they have a Hadoop solution where they take all this IoT data that they're getting out of your cars. And with Progressive, you can sign up for this little thing that you stick in your car, and it tells them a little bit about your driving. And they ask for the data, and in return, what they'll do is they'll give you a customized quote based on what you do, how you drive. Now, I live in Los Angeles. Freeways are 80, 85 miles an hour for everybody, and so they adjust accordingly. But they're able to see, hey, maybe this is a 16-year-old kid driving 85 miles an hour down the surface streets. Maybe it's a 16-year-old kid who's driving 85 miles an hour everywhere they go. Or maybe this is a 16-year-old kid who's actually responsible and follows the speed limits. And they're able to take all that data and customize a policy. Now you think, how do you do that, right? You have this structured data that's your traditional data, something like a customer. So I have customer, policy type, age of drivers, cars, like all that traditional structured data. And I have this now data emission coming from all of these cars I'm landing somewhere. Well, about 5 years ago, there was this new thing that got introduced, Uber, Lyft, right? These new car services that were no longer something that people would traditionally do with their cars. I wasn't driving a taxi service. That's not what I did. That's my spare time. That's not what I was doing. But now I may think about being an Uber driver. And in the US, there was a lawsuit that happened, and I don't remember who got sued. But it was a company that was running one of these car services, something akin to Uber and Lyft. And they got sued because there was an accident. And the passenger in the backseat of the car sued the driver and then sued the company that they worked for. And because they didn't have the appropriate commercial driving insurance, the appropriate commercial driving policy, the insurance company had to pay out a very large sum of money. So when Progressive saw this, they said, hey, maybe we should start to figure out who are our commercial drivers. So what they did was they took all this telemetry data, and they took it and combined it with their T-SQL structured data. They said, go find me all of the people who have a non-commercial policy that went to the airport 5 times this week. Because who went to the airport 5 times this week that isn't an Uber driver? It's not me. Or who went to 5 bars on a Friday night, or 10 bars on a Friday night, back and forth and back and forth. And they said, if they don't have a commercial policy, now this is an opportunity for us to go market to those folks and say, hey, we've developed a new program for these new types of driving patterns. If you're an Uber or Lyft driver, you should buy one of these new policies and it'll cover you in the case of an accident. And they were able to run their business and move their business forward and tailor their business to the customers who are actually pertaining in those situations. I personally didn't get that advertisement, but some of my neighbors did who were actually Uber drivers. And so they were able to customize all of this behavior based on just things that they were learning from these different environments. And Polybase allowed them to do that. So instead of actually continuing to talk about it, I'm going to show you. So I've created another contrived scenario. I've got a meters file. So you can imagine, again, this is a utilities company, and so they have gas meters. Let's just play the gas meter scenario. And each one of these is set up where, in this case, it's a table. So it's going to have an ID column, and then it's going to have a serial number. In this case, I just created a GUID, just for ease of generation of data. But it's the unique serial number of that meter. And so you can see I have it just in a flat file here. It's just comma delimited, nothing special about it. And we can pop over to Azure Explorer here, and you can see I actually have this in Azure Blob Storage. So in my Azure demo account, I have a blog container called a datum, and inside of that I have my meters.txt file. And so I want to now go get that data. It could have been generated from any different kind of way. I want to go get that data and ingest it into the system. I'm going to walk you through how Polybase does this. So the first thing we're going to do is we're going to create what's called a master key. And this is a key that's used to then encrypt all of our credentials to make them secure. Now in this case, I didn't add a password or anything like that. You could do that as well. But I just chose to just make it simple here for the demo. And the next thing I'm going to do is I'm actually going to go create a scope credential. So in this case, you can see it's essentially just a name of a credential, and then it's the key to that Azure Blob Storage that I just showed you. And so it's just a really long string. And I'm going to create this credential. And now that that's created, I want to describe that file format. In this case, it was a simple CSV, so comma-separated value. So I'm just telling it, hey, this is a delimited text file, and it's separated by commas. So super simple. You have control over formats like dates and those kinds of things, reject rows and error rows and all those kinds of things. But again, I'm making a very simple example here. So we can go ahead and execute that. And now the system knows about this format that I want to use. The last thing I'm going to need to do to get this set up is I'm going to create a data source. So I need to tell SQL Data Warehouse where to go get that data. And in this case, I'm telling it, here's my container, here's the blob store that I want to run it in, and here's the credentials used to go connect to that. And then we create it. Now the last thing I'm going to introduce you to this concept of is an external table. Now from a SQL Server or SQL Data Warehouse perspective, it's a table that's backed by data that's not sourced in SQL DW. It's fulfilled by Polybase. And in this case, it's going out to blob storage, so there's no compute on the blob side, so it's just going to stream all the data in. But it's configured in a way that you say, here's the columns I have, so just like regular T-SQL. I'm going to tell it where to get that file, and in this case, I gave it a particular file name. I could give it a directory, and it'll do directory transversal, so it'll go through all of the files in the directory. I'm going to tell it the data source, so where in the blob storage to go get it. And then finally, I'm going to tell it what format it is. And so I can simply create this. And it takes just a second. And if I wanted to go check, I can go see how many rows are actually in that text file. So what just happened in that split second that you saw from the time I walked from there to here was this system generated a query to all of the nodes. They went out to the file. They read in parallel chunks of the file, aggregated the number of results they had, returned it to the control node, and then showed it to you on the screen. That happened in a split second, a couple 100,000 rows. So it was able to do that very, very rapidly. And the reason why I started with this whole why do we have MPP, why do we have all of these different kind of threading models, is because this was all done in parallel. So we started with the BCP example. It was a single thread running through the system loading data at 10,000 rows. And in this case, now we had a set of threads. This is set at a DW1000, so 10 threads essentially working in parallel to go get that data and ingest it very rapidly. Yeah?
Can you look at an execution plan? Does that work?
We can. So I won't do it here. It'll kind of slow us down a little bit, but stay after, and I'll definitely walk you through how this actually happened. Yeah?
In the statement where you loaded, you didn't say how that file was limited, so how did it know how?
You kind of missed it. So I did actually say up here in the format, in the file format, I told it what the field delimiter was. It was comma. So it was there. I could delimit it on whatever I want. It also can define different date formats, for example. So if you have date formats coming from different services, there's different services, you can set it up that way. So let's kind of move on from here. So if we look at kind of this now, I'm going to introduce you to one last thing with this service. So we have this concept where we call it a CTAS statement, or create table as select. So I have a bunch of data sitting in that external data source, and I could use that if I wanted. But if I wanted more kind of real-time operation or faster access to the data, especially in this case, it's only a couple 100,000 rows. But what if you had a billion rows in external files that you were trying to ingest? And so we use this concept of a CTAS, which is essentially go create a table from a query. And in this case, I'm going to define a new table. And you can see it's just called dbo.meters. And in this case, I don't have to define the columns because I'm going to do that in my select statement. And again, I added these additional details just so you could see the parameters that we use. And I chose just a different type. So you can see I'm now going to say this is distributed on this ID column. There's a whole set of performance reasons why we do this, the way that the queries get optimized later. I'm going to give it a different indexing type. So in this case, I'm going to say it's a heap, not a cluster column store index. And then I'm simply going to say as select. And I'm going to go out to that external table. And I'm going to get the ID. And in this case, I'm going to change the data type because I know those are unique identifiers. In my external definition, I define that as just an n varchar, so a bunch of string characters. But I actually want this to be strongly typed. So I can create that conversion here in the select statement and then just execute this. Now if I execute this, right now SQL DW is going and generating a brand new table, and it just imported all 390,000 rows into that table. Took just a couple of seconds. Now you can see the power of being able to do this very quickly. Even with 10,000 rows, you could see the lines going by, but that took just a couple of seconds versus 390,000 rows, which was almost instantaneous, generating a new table and loading all of that data. And now if I go just do a simple select star from my new table, you'll see it returns almost immediately. It now has that data local and accessible inside of the system. We're able to ingest it very, very rapidly. And so it gives us the ability to move that data in very fast into a system, be able to absorb all of that using this power of the scale-out compute capabilities. And so now we have a simple kind of model set up. So I'm going to pivot back to our deck for just a moment. And we're going to kind of build on this scenario. I'm going to take us down a detour, and I promise I'll come back. So when we think about kind of all of the partners that are enabled here, I promised I would use a partner here instead of just Microsoft technologies. There's a suite of partners. This is the SQL Server ecosystem, so it's a very broad set. This is just a sampling of companies that are built around the SQL Server environment, whether that's with tooling, whether that's with integration services, whether that's in consulting, that offer all kinds of capabilities to blow out your business, whether that's new technologies, integration of data, visualizations, all kinds of different ways, whether that's monitoring of the data warehouse, understanding how the data is moving through the system using tools that you maybe already have in place. And so because this is SQL Server, it gives you most of the capabilities that SQL Server has. There's a couple small differences, but really it gives you the capabilities of using the tools that you have. And this large ecosystem of customers really gives you the capability of what you already know, the tooling you have in place, and lifting and shifting your data warehouse to the cloud without having to rebuild your entire environment. And it really gives you this kind of a speed to opportunity metric that you can use to say, I can get my data warehouse there, I can use the power of the scale-out relational data warehouse, and then I can go take advantage of the tooling we already have in place. I don't have to regenerate, say, my Tableau reports, for example. I don't have to go do that. I just point them at a new data source, and I can take advantage of this power. I'm going to pick a particular one out of here. It's called Redgate Software, and they build a bunch of tools around SQL Server. So they've been a partner with us for a little bit, and as we were developing this service, they went off and built a solution called the Data Platform Studio. And what it does is it helps you move data from on-premise SQL Server to the cloud. And it gives it a whole set of abilities to do this very quickly. Now I did it through T-SQL here with Polybase as one way, but you can imagine moving data from your on-premise solution looks something like export that data, land it in blob storage, create all this tables, ingest it through a CTAS statement, so it's a bit of work. So instead of doing that, we can kind of walk through their solution. We'll show you how you can do this by just clicking through visualization. So we're going to go ahead and log in. I'm already logged into their site. This is just an online site. And we're going to start one of their new wizards. So we're going to import data to SQL Data Warehouse. And we start with this concept of a gateway. And you can imagine a cloud service having to reach into your environment has to have some way to do this. Both Redgate and the Azure Data Factory offer a gateway concept, which is essentially a small piece of code running on a machine somewhere that allows the cloud to reach through that gateway in order to get into your environment. So it's something you have to install. I've already installed it here. And you're going to see my lovely laptop machine name. So this is the machine that it's actually running on, which is this local laptop here. And then I'm going to go tell it the server that I want it to connect to. And I can never remember that. So I'm just going to copy and paste here. And it's going to connect here to my local laptop. Oh, I timed out. We'll go through that part again. So we'll connect back to our gateway. Use my local machine name here. And now what it's going to do is it's going to reach through the cloud into my laptop, and it's going to ask what database do I want to connect to. And you can see I have a demo DW. And what it's going to do is it's going to now go query that, and it's going to say, well, what table do you want, or what sets of tables do you want to import? So I have this customer meters table that I want to import, and it's the mapping between my customers and the meters that are at their houses. So pretty straight example. So how do I attach these two together? So I'm going to select that one, and I'm going to click Next. And now what it's going to do is it's going to go out and it's going to use Polybase under the covers to go pull all that data out of my local SQL server, going to land it in blob storage, generate all the Polybase scripts for me, import the data, and do that without me having to go create all those scripts. In this case, it's going to ask for an existing storage account. And I'm going to use one that I already have on where it wants to land that data. Now it's going to go into my Azure subscription. It's going to look for the data warehouses that I'm connected to. And this is going to take a minute. I work at Microsoft. We have about 8 subscriptions you'll see here in a minute. We have a lot that we use internally. So this is going to take a second for it to load because it takes a while for it to go read. But it'll essentially give me the ability to connect to one of my existing data warehouses and be able to say this is the target of where I want it to go. And again, I apologize for the slow internet connection here in the room. But really this is the capability of you not having to remember, okay, what's the server name, what's the connectivity? Oh, there it goes. And how do I go and connect? So I'm just going to type demo DW, and you can see it's on the Azure server, which is my server, and it's only going to ask me for my password. And hold on, it's a little hard here with the resolutions we've got. I'm going to guess at where that button is. That's the problem with doing live demos. 1, 2, see if we can make next. All right, hold on. I'm going to have to change resolution so I can actually see the next button on the screen. Hopefully it doesn't mess that up too bad. Okay, so I actually did hit it. So now it's going to say, okay, I went a little too far in this demo, went a little bit too far. So now we're going to go back to there. We're going to pick our database name, and it'll now go connect to that data warehouse. So it's going to say, okay, I've now connected to the data warehouse, and because I've chosen the table, and in this case it doesn't have a table that's already named that, it's going to ask me to start importing. And so all of that T-SQL scripting that I did with Polybase, the creating master keys, all of that in structure I had to do, it's now going to do on its own. So this cloud service is able to take all of that information, reach into my environment, which is, again, here is my laptop in this case. It's just going to reach down, and it's going to start to generate all of those scripts. And it means that I don't have to go do this. I can quickly go through a kind of a simple import scenario where I have all of this data in SQL Server. I can get my stuff to the cloud very fast. And in just a moment, you can see it's going to start the process. And this first dialog is what it's showing you is it actually went into my environment, queried my SQL database on my laptop here, ingested all that data into a file format, uploaded that into my Azure Blob account. It's now in the process of generating all of the scripts it needs via Polybase to go import that now into my structured tables inside of SQL Data Warehouse. And in just a minute, it'll start the process of doing that, actually moving the data from Blob storage through Polybase into that SQL Data Warehouse. And again, for some reason here, I've tried this a couple times before you came in the room, and the demo's a little slow on why this is kind of importing data. I don't know what's going on here. It seems to be something with my connectivity here in the room. But this is the process that's happening under the covers. And so it's able to move that data very, very rapidly. And yeah, go ahead.
Yeah, whose blob storage is that? Is it yours or is it Redgate?
This was actually mine. So in about the second step, you saw me pick the Azure demo blob storage. So I actually get to define where it is. So in this case, I used an existing one because I didn't want to go through the process of creating a new one. But you could also generate a new one. So you can see it's about 80% done. So it's actually generating all of the data and moving it through. And as soon as this is done, you can see it says it took 11 seconds. For some reason, again, in this environment here, I'm not sure what's going on in the room, but for some reason it took a little longer than it usually does. But it took all of the data from my SQL Server instance sitting on my laptop, ran it through the gateway, pushed it into the cloud, and did this through just a set of clicks. I saw a question here in front.
Authentication of your local laptop SQL Server, is it on the gateway server? That's how you could connect it to your laptop?
Yeah, so the question is, how did I essentially authenticate to my laptop? You can actually do it through SQL Server auth, or you can do it through Windows auth. In this case, I actually did it through Windows authentication.
Gateway server and your server?
What's that?
That's between the Redgate gateway server and your laptop.
Yeah, so the Redgate cloud service, it actually gives the configuration information to the gateway, and it runs it locally against your machine, so it can essentially export the data. And so you can control that. You could set up specific users that only have, say, export rights or select rights. It couldn't manipulate data, that kind of thing, or only access to particular tables. So you don't have to worry about the cloud service there being able to access your information. Yeah, when I set up, so the question is, how did I do it? In the gateway, when I downloaded the gateway, I configured kind of the integration I wanted. And then when I connected to my local machine, you saw I just had to, I skipped over kind of the password information. Yeah. So in this case, I just did it kind of, I kind of cheated. I gave you the Cliff Notes version. There's a little more advanced version, but I gave you the Cliff Notes version so you can see this. So if we go back to our T-SQL, and I'm going to minimize this back down again. Sorry for the screen resolution changes here. Try to get this back to optimal for the screen. If we go back, now you'll see what I would have done was I would have created a table on my own. I would have said, hey, here's the kind of table I want to create. But you can see I've commented it out because it was already generated by this tool. And I can now just simply go select top 100 from that table that was imported from SQL Server on my desktop. And if I wanted to do something specific now I can take all of that data that I generated so far, my customers, the meters, and then the join of that data. And I got some of this from BCP file, just from a file. I got some of it via Polybase through a file sitting in Azure Blob Storage. And the connection between the two was done from my local laptop through Redgate software. I can now simply run a query for all that data, and you'll now start to see, Anthony Evans here, who's an English, has English language, is a male. This is the meter that is attached to his house. And so you can see I can take all of these data sources, I can combine them into a data warehouse using a variety of technologies to do this. The last thing I want to show you with this is if we go back into the Azure portal, Microsoft has a technology called the Azure Data Factory. And so it has a very similar concept, and the walkthrough is very similar. I'm not going to walk you through it again. And essentially, you can go create a data factory, and you can create a copy action, which is essentially a copy from a bunch of different sources into the Azure SQL Data Warehouse as a target. Now, it offers capabilities beyond just SQL Data Warehouse as a target. You can target many of the Azure services, and it has the same kind of concept. So we're going to just walk through just a couple of screens so you can see. These are a set of data sources that you can come from. You can see obviously blob storage and table storage, but you also see things like on-premise SQL Server. You'll see Oracle, which can be on-premise, and it uses the same gateway technology to reach into your environment to be able to move data. And it can target back and forth. All right, so as we kind of wrap up, it was very kind of short in the amount of time it took me to generate a brand new data warehouse, the amount of time it took me to scale, the time it took me to create a database, and start to ingest data. Now, I get this was a contrived example. The idea is to walk you through some of the ways that you can do this and some of the pros and cons of each. So kind of in summary, as we start to close here, we think about kind of the way that Azure SQL Data Warehouse works. It's really built on these kind of 4 key kind of models. This enables transformative insights, this ability to separate storage and compute, and the capabilities that it offers with this MPP architecture to scale out these relational data warehouses to hundreds of terabytes to petabytes of scale, to really give you the capability to have your business start with a service and grow with the business as your business grows, as you need more from your data warehouse, the ability to get started and move quickly as your business grows and not have to think, well, I don't know what my business is going to look like in 3 years. Maybe I'll need something super big, so I should buy something big now, but I'm not going to use it effectively for the next 2 years. So how do I scale my system? The ability to secure all that data once it's running in the cloud. And finally, getting you up and running quickly. So you don't have to go through the process of calling IT, buying hardware, getting that racked and stacked and lit, installed software, configured, which could take days, weeks, months, sometimes years to get that all through your environment. So really being able to build a solution, get into the cloud, and scale very quickly is what SQL Data Warehouse offers. So I'm going to leave you with a set of online resources. So this is a couple of ways to get started with the SQL Data Warehouse service. These are all short links from Microsoft. So AKAMS is Microsoft's version of BitLily, if you're familiar. So this is a way to get started with the SQL Data Warehouse service. So you can go to, the first link will take you to kind of our overview page, give you a lot more information about the service itself. The next one is a link for some developer services or developer references, so some of the language surface that we have. The third one is really a community. So we use Stack Overflow quite extensively. We have a tag on Stack Overflow. You can post questions. A lot of the PMs like myself hang out there and answer questions. Get help. It's a good way to engage with us directly. So if you have questions on how to get started, if you get stuck by something, some of the questions in the room, for example, it's a great way to ask questions. And then finally, a couple of kind of getting started videos. So some of the examples I've given you here kind of blown out in video form so you can watch through how people have built solutions. With that, I'm going to hang out for a few minutes. So if there's questions beyond kind of what I've presented so far, feel free to come up and see me after. So there's an additional set of resources that you can get from Microsoft here from being here at the Ignite conference. This is kind of one of those standard slides. You've probably seen this about 20 times already. So this is an additional set of resources I'm supposed to show you. And so I'll go back to this one so you can kind of watch the online resources for Azure SQL DW. So I appreciate your about an hour of hanging out with me here. I hope I didn't bore you too much. It seems like everybody's still awake. I don't see any heads bobbing at me, which is a good sign. And enjoy the rest of your time here at Ignite. Thank you.